Module 2 says to show that sine 2 theta is 2 tan theta over 1 plus tan square theta. So let's do that. So one thing I like to do is I like to start with my left-hand side. So you're always going to see me, right? LHS. LHS, left-hand side. The left-hand side is equal to sine 2 theta. Now sine 2 theta is the same as 2 sine theta cos theta. That's sine 2 theta. 2 sine theta cos theta. Everybody agree with that? That's just a double angle formula. Now look what I'm going to do next. Now I'm going to write up here tan theta. What is tan theta? Everyone knows that tan theta is sine theta over cos theta. I know I'm writing it a little small, but it's because it's not really a part of the proof. So if you were to cross multiply, you can actually see that sine theta would be equal to tan theta cos theta. That's all I'm saying, that sine theta is actually equal to cos theta tan theta. Aha. So look what I'm going to do. So what I'm going to do is write this out now as 2 times sine theta. I'm going to replace it as tan theta times cos theta. But no, cos theta times this cos theta is going to give me cos square theta. Aha. But cos square theta is what? Cos square theta, as I know it, is 1 over sec square. And so this works out to be 2 times square theta over sec square theta. This don't look like theta, let's fix that. 2 times square theta, 2 tan theta over sec square theta. But then what is sec square? Sec square is 1 plus tan square. All right, so now we can write that this is actually 2 tan theta over 1 plus tan square. Nice and easy, and that's how we get right hand side. Nice and easy, soft. So that's part 1. Part 2 now, part 2 says, hence or otherwise, solve sine 2 theta minus tan theta equals 0. Hence or otherwise, solve sine 2 theta minus tan theta equal to 0. Now if we're solving sine 2 theta minus tan theta is equal to 0, then we really don't have any issues. All right, why we don't have any issues? That's because sine 2 theta is this identity right here. And so you can rewrite this now with 2 tan theta over 1 plus tan square theta minus tan theta is equal to 0. Now, I don't like when my equations equal 0, so I was going to bring over tan theta and then multiply through by 1 plus tan square. But you can just go ahead and do it from right here. So we're going to multiply through by 1 plus tan square. So we're going to multiply the equation by 1 plus tan square theta. If you multiply the equation by 1 plus tan square theta, it's going to automatically become 2 tan theta minus, now tan theta times 1, that's just minus tan theta. Then minus tan theta times tan square theta is minus tan cube theta. All right, so this is what we have now. So we have a cubic equation in tan. So let's go ahead and solve this tan equation. I don't like when this term is negative, so I'm going to multiply through by -1 to rewrite it as tan cube theta Now 2 tan theta minus tan theta is tan theta, but since I multiply through -1, it's just going to become minus tan theta. So I just get tan cube theta minus tan theta is equal to 0. I can then go ahead and factorize tan theta, and factorizing tan theta from it, I end up getting tan square minus 1. Tan square theta minus 1. And this is of course equal to 0. Now if I'm solving this equation, then it's either I'm solving tan theta must be equal to 0, or if tan theta is 0, the other equation is that tan square theta is equal to 1. All right, now if tan square theta is equal to 1, then this equation is telling me that tan theta is equal to plus or minus 1. Plus or minus 1. Now let's first look at when tan theta is 0. You draw your circle. You know that tan is positive in the first quadrant and the third quadrant. Then what is tan inverse of 0? Tan inverse of 0 is 0, and so the two solutions are going to be 0 and pi. That's from these two quadrants. Now looking at this now, since it says plus or minus 1, you're going to want the solution from every quadrant, every diggy quadrant, first, second, third, and the fourth. So first find tan inverse of 1, and you want the answer in radians. So tan inverse of 1 is going to be pi by 4. Then the solution in the second quadrant is going to be pi minus pi by 4. Then the solution in the third quadrant is going to be pi plus pi by 4. And then the solution in the fourth quadrant is 2 pi minus pi by 4. Nice and easy. So that's how we get this now. So finally we can write down our values for theta. So the final answer is going to be theta is actually equal to 0, or theta is equal to pi by 4. I'm just putting them in order. Or theta is equal to pi minus pi by 4, which is 3 pi by 4. Or theta is equal to pi, or theta is equal to, this looks like 5 pi by 4. Or theta is equal to 2 pi minus pi by 4, which is 7 pi by 4. Nice and easy. Nice. And that takes care of this question. Nice and easy, soft. Now all you require to do is plug it in theta as 0, sine of 0 minus tan of 0 is 0, put in pi by 4, which is 180 over 445. Just checking the answers when you have sine 90 minus tan 90. Oh, pi by 445, yeah, this is fine. Try 3 pi by 4 as well. All of them is going to be right. All right, so that's the solution for theta. Nice. Now part B. Part B now is saying that express f of theta in the r cos theta plus alpha form. So let's write down f of theta. F of theta is equal to 3 cos theta minus 4 sine theta. Now to put it in the r cos form is very easy. First you need to find r, and r is equal to the square root of a squared plus b squared. So r is going to be equal to the square root of 3 squared plus 4 squared. The square root of 3 squared plus 4 squared, that's just the square root of 25, and the square root of 25 is 5. So that's r. The next thing we need to find is alpha. How do we find alpha? Alpha is tan inverse of b over a. So it's tan inverse of 4 over 3. So you put that in your calculator, and what are you going to get? Tan inverse of 4 over 3. You want it in radians. Getting 0.927. 0.927. And so finally, what we can then conclude is that f of theta is going to be equal to r, which is 5, times the cosine of theta plus alpha. So it's 5 times the cosine of theta plus 0.927. That's going to be f of theta. 5 cosine theta plus 0.927. After you do that, now it says, so this is part 1. Part 2 asking us to find, part 2a asking us to find the maximum value of theta. Now the maximum value of theta is 5. Maximum value is 5. The maximum value of a cosine function is the amplitude, and the amplitude is 5. Now they say find the minimum value of 1 over a plus f of theta. Now for the second part, look what we're going to start with. What I wanted to start with is to say that the function f of theta, it's always going to be bounded between 5 and minus 5. It's always going to be bounded between 5 and minus 5. And so if you add 8 to it, you're going to say that 8 plus f of theta is going to be bounded between, adding 8 to 5, 8 plus 5 is 13, and adding 8 to minus 5 is 8 minus 5, which is 3. And so 1 over 8 plus f of theta is going to actually be bounded between 1 over 3, so it's going to be now less than or equal to 1 over 3, but greater than or equal to 1 over 13. Once you are flipping, you change the signs, all right? And so what we can then conclude is that the minimum value will be 1 over 13. All right, so let's write that down in a formal manner. So the minimum value of whatever minimum value is 1 over 13. That's it. So the minimum value of 1 over 8 plus f of theta is 1 over 13. Nice, that takes care of that. Now let's go to part C. Part C is saying that given that the sum of angles of a triangle is pi, show that the sine of A is equal to the sine of B plus the sine of C. Now, first thing I want to start with is that A, B, and C are angles of a triangle. So let's work this out. Let's do this question. A, B, and C are angles of a triangle. A, B, and C are angles of one triangle. So if that is true, then clearly the angle A plus the angle B plus the angle C must be equal to 180 degrees. And so if I were to subtract B plus C, I would get that A is equal to 180 minus, in bracket, B plus C, right? That's how I would make A the subject. I'm then going to take the sine of both sides. And so what I'm saying is that the sine of A is equal to the sine of 180 minus B plus C. Now, what I'm getting then is the sine of A is equal to, now think of this as the sine of, think of it as the sine of A minus B. Think of this as the sine of A minus B. So this is going to equal to the sine of 180 times the cos of B plus C minus the cosine of 180 times the sine of B plus C. So what I'm getting now is that the sine of A is equal to, the sine of 180 is 0. So this works out to be 0 minus the cosine of 180 is minus 1. That's now minus 1 times the sine of B plus C. Nice. And so what we finally get now is that the sine of A is equal to minus become plus, so that works out to be the sine of B plus C. So the sine of A is the sine of B plus C. Nice and easy. Soft. Now since the sine of A is equal to the sine of B plus C, it is proven. Nice. Now let's look at the next part. For the next part, it says, show that sine A plus sine B plus sine C is equal to that thing there. Now all I'm going to do is, since sine A is equal to the sine of B plus C, then what I then know is, then the sine of B is going to be equal to the sine of A plus C, and then the sine of C must be equal to, the sine of C must be equal to the sine of A plus B. Nice. Hence, what does that mean then? Hence, the sine of A plus the sine of B plus the sine of C is going to work out to be the sine of B plus C plus the sine of B, which is A plus C, plus the sine of A plus B. And that's what we have. All right, the only thing is that the order is different. So let's know, but then now addition is commutative. So but addition is commutative. The order in which we add doesn't matter. And so the sine of A plus the sine of B plus the sine of C must be equal to the sine of A plus B plus the sine of B plus C plus the sine of A plus C. That takes care of question 3. Nice and easy. Soft. Nice.